Part 4, surface area of composite solids. So here we go. We're looking at our 4th video in this line. We're going to do 2 examples in this video and 2 examples in the next video for a total of 10 unique examples of surface area. As I mentioned many times before, surface area is a little bit more challenging than volume of composites. And well, first of all, what do we mean when we say composites? Composite solids are quite simply just like combinations of solids. In this case, you can see that we have a hemisphere with a cone on top. So to find the surface area of the total thing, you're going to take the surface area of the hemisphere and you're going to add it to the surface area of the cone. But there might be some parts that we need to delete. So let's think about this for a second. Hemisphere surface area. Well, if we think about an entire sphere, surface area is 4 pi r squared. We only want half of that though, so let's cut it in half. So that's 2 pi r squared. A cone has, let's see, we have a circle at the bottom plus the part that kind of wraps around it, the lateral surface area. But if you think about this for a second, the bottom of this cone, the base that it sits on, well, that's of course a circle, but it's also smushed in between the hemisphere, right? It's not on the surface at all, so we're going to get rid of that. We don't want to calculate stuff that we don't need. The pi RL represents the part that wraps around the cone. All of this up here. Okay. So let us put in what we know. We know that the radius is 28. But we do not know the slant height. Remember, the slant height is, you know, this measurement right here. It goes down the sort of the edge of the cone, if you will, down the slanted part. So our job is to find out what that is. And if you need a little bit more refresher on that, please go back to the videos that have cones and pyramids and things. But what we're going to do here is we're going to hopefully see that we're looking at a right triangle, and since it's a right triangle, we're going to go Pythagorean Theorem. So 49 squared plus 28 squared equals L squared, and that'll give you your slant height. That's your slant height. So that goes over here. So if you type everything into your calculator now, you get a total surface area of, let's see here, about 9890.37, and that is square feet. Cool. Number 2 is not so cool. This one is a little bit more challenging. We're going to try to find the surface area of the entire solid. Now, first things first, let's understand what this actually is. This is a cylinder with a cylinder removed from it. Alright, so you can imagine maybe like a roll of paper towels or something, or maybe a washer or something like that, right? It's basically a ring with a ring and the ring taken out of it, if you will. Something like that. So we need to find the total surface area of the composite solid. Alright, so let's do it this way this time. Let's go and say, alright, let's look at the top of this. So I'm going to highlight this in yellow. That's not a very good job. I'm going to highlight this top in yellow, and we're going to try to find the area of it. What's the area of that portion in yellow? That's question number 1. Well, it's going to be if we were to look at this from the top, it would be a circle, which is not easy to draw. It would be a circle, and the distance from here to here is 9, and the distance from here to here is 5. And if we're asked to find just the area of the yellow region, all we're going to do is take the area of the big one, area of the big circle, minus the area of the small circle. And that will give you the area of the yellow region. There are 2 of those, so let's do that twice. Let's take that value, and you can either add it to itself or multiply it by 2, totally up to you. But that's the top and the bottom. Okay, so we then go for, let me erase this picture, then we go for, let's go to the sides next. So this right here. If you're thinking about this maybe as like a, I don't know, a can of soup or something like that, this would be the label of the soup can. So we need to figure out the area of that. We're going to add it to the rest of this. Well, the area of that thing is actually just a rectangle, right? So when we think about, this is kind of like a cylinder. So the cylinder surface area is this formula. So it's super important to understand how these formulas are actually made up. The 2 pi r squared is the circles on the top and bottom. It's a circle times 2, which means this is the lateral or the side surface area. This is all the part that you would probably consider to be like the side or the label of the soup can. Alright, so we don't want to deal with the top and bottom. We've already really taken that into account up here. But instead we just want the lateral surface area. So we go 2 times pi times r, which is, well, r of the whole thing is 9. Let's choose that r times the height. And you might think that you're finished, but you're not. If you think about this, we need to go inside of our figure and think about the fact that there is on the surface this whole inner cylinder. This whole inner cylinder, believe it or not, is on the surface. And I know that because think about it this way: if we were to ask ourselves the question, what part of this whole solid is being hit by air? In other words, what part is on the surface that the air is actually touching it? You would have to include this purple section because air is getting inside of there, so it is on the surface. In other words, maybe think about it this way: if we had to paint this whole thing these colors, you would need yellow for the top and bottom, green for the side, and purple for the inside. But just because it's on the inside doesn't mean we have to that we can forget about it. We have to add it to everything else, and that is, of course, the sort of the wrapped around lateral surface area of the inner cylinder. The inner cylinder this time has a radius of 5, so use that one, same height, and I think that will give you the whole entire surface area of the whole thing. And if you type all that stuff in, you get about 615.752. So that was a little bit challenging, I think. We'll have one more video with 2 examples coming up.